Hello, and welcome to another episode of Adventures on the Can-Do podcast. I'm your host, Jothy Rosenberg, aka the Incorrigible Entrepreneur. A professor turned entrepreneur and founder of 9 companies. On this show, I talk with business leaders and personal achievers. Adventures on the Can-Do explores the challenges and rewards of entrepreneurship, overcoming adversity, and where grit and perseverance can get you. Be inspired by others and push yourself along your path to success and fulfillment. My forthcoming book, Think Like a Startup Founder, based on my experiences, good and bad, seeks to help early-stage startup founders avoid the oh-so-many pitfalls founders can experience along the way. Adventures on the Can-Do adds to that the stories of many other founders, each with an amazing story and set of lessons learned that will be valuable to listeners. Before we jump into today's episode, just a reminder of how you can support this podcast. You can go to my website at jothyrosenberg.com and sign up for my newsletter, and there you can also see other episodes of this podcast. Also, please follow and rate us at podchaser.com/adventuresonthecan-do, all one word. And with that behind us, let me introduce today's guest, Rob Oshana. Rob has a BS in electrical engineering from Worcester Polytech Institute and a PhD in computer science from Southern Methodist University. He currently is SVP of Software and Security at Analog Devices in Austin, Texas. Previously, he was Vice President of Software Engineering, Research and Development and Edge Processing at NXP Semiconductors, where he managed a global team of software engineers developing runtime enablement, application software, and tools for multiple business lines, including auto, consumer, media, Internet of Things, industrial, networking, and mass market. Rob was chairman of the NXP Software Technology Board, leading cross-company efforts focused on software reuse, efficiency, collaboration, and cross-business alignment for multiple software business units. He has been on multiple university advisory boards and research boards. And for over 25 years, he has been adjunct professor at Southern Methodist University, the University of Texas, and Concordia University. He has been an international speaker on topics related to software engineering, Internet of Things, embedded systems, multi-core software, software testing, and software quality. Rob has over 200 publications and presentations and 4 books to his name. Please meet Rob Oshana. Hey, Rob.
Hey, Jothy, how are you doing?
Great. You're looking like you're leading the big corporate life right now.
Yeah.
So,
yeah.
And we'll get into some more of that, the big company stuff, because I think I've got some questions there that the audience will enjoy. But I first wanted to just go back to how we originally met, because so we were both connected to a technology that is pretty interesting. It's called RISC-V, which is kind of a strange name to people that aren't deeply immersed in the business. We won't go through all of what it stands for, but the idea is it's a new processor. It's an architecture where the architecture, the instruction set is open sourced, so everybody can use, can see it and can work together to improve it, and isn't paying to license that. And then everybody can implement that how they want. And that still leaves lots of opportunities for companies to, make plenty of money around it. So we were both at a RISC-V smallish meeting held at the Google facilities in Mountain View. And apparently what had happened is you'd ask the guy that was in charge of the sort of standards group behind RISC-V. You asked him, is anybody doing security for this? And he said my name and that I would be at this meeting and you should find me. and
Yeah.
You walk up and you go, are you Jothy Rosenberg? And if so, come on, we got to talk. And what was really funny about it to me in the end was that everybody in startup land dreams to find a great lighthouse customer. Well, you were a lighthouse customer that found me.
Yeah. Yeah, no, exactly. We are looking for innovation, and we found it in you and your company at the time. And yeah, a little bit opposite the way it normally works, but worked out well.
It sure did, and it was like a dream. And I'm going to avoid getting you in any trouble and mentioning the name of your former company, but um, that was a company that tried to stay on the forefront, and maybe even take some risks, which is interesting because we always talk about startups being able to take some risks. We ended up working closely together for years, just because I think, well, things changed a few times, and it's a big company, and a product isn't that interesting to you guys unless you are sure you can ship 100 million chips. I think I got that number right, isn't it? About 100 million.
Yeah, yeah, yeah.
These
It's
are
in
big.
that. They're big numbers, aren't they? Yeah.
These are big numbers.
Yeah, when you're growing, a new business, the LSP gets really high when you're dealing with broad market like IoT or something like that. The numbers get really really big really fast.
Well, yeah, and I'm just going to explain acronyms. So, because I'm not sure, if everybody's heard of these things. So Rob's done a lot of work in what's called Internet of Things, and it's all these devices that are connected to the internet, and there literally are tens of billions of them. No exaggeration. There's a lot, and if every one of them has a chip from your former company, or your current company for that matter, well, you don't have to charge that much for them to make a lot of money. That's the thing about huge numbers.
Yeah, no, that's right, and you still want to be able to innovate as well though, because there is a lot of competitors out there. So you're always looking for innovation. And the other thing about the Internet of Things, when you got so many different types of devices deployed, is how to secure them, right? And that was our big challenge at the time, was not just how to secure them, uh, but how to do it in an innovative way to differentiate ourselves. And that's what we were looking for when we first started looking at RISC-V, and then how can we add some security extensions to that instruction set architecture. That was the motivation for that.
So, just wanted to kind of go back to the whole Lighthouse thing. So, from sitting in the seat of someone on the big company side, on the side of being the Lighthouse customer, how did you sort of how did you think that the process would work, and not in a detailed level, but just in terms, because let me just say this, that from the startup standpoint, the purpose of a Lighthouse customer is to get to a minimum viable product that customer is basically acting as a proxy for the market, and is helping you understand what is it going to take to make something that people in this market, including the Lighthouse customer, would buy. And so what did it look like from your side? That's what it looked like from ours.
Let's go through the process of kind of a build versus buy first of all. And so it's always a discussion about organic or inorganic options when we're looking to differentiate in a specific area, first of all. And so and we know we're not going to always find the absolute perfect innovation that just kind of plops in, but it's got to be in the vector that we're looking at, and I think that's what we saw at the time with your company, was that the innovation was there, didn't exactly check all the boxes as far as low power, which is what we we're really looking for with these microcontrollers. or even on the software side and the tooling side. But there was enough there that interests us that if we work together with you, we can help in those areas and kind of get to a win-win. So it wasn't we weren't looking for all the boxes being checked straight away. We were just looking for the raw core innovation that we can build upon.
And I mean, work together is an understatement, because we ended up. I think our engineering team met with the counterpart team pretty much every Friday.
Yeah.
And that went on for, I would say, at least 3 years overall.
Yeah, and that was a great relationship, great partnership, because I think we learned from each other, and again, the common goal was to get to a point where we had something that really differentiated us, and also helped us, and the team was both sides. I remember those days were working very collaboratively together, sharing knowledge and building, evolving this technology going forward. One of the few times I really saw it work that collaboratively for so long.
And I'd never have seen it from that a big company would make that kind of a commitment and work with a small company that way. It was pretty amazing. And one of the things that I mean, you pushed us hard, and ultimately the thing that you pushed us the hardest on was what's so important on these very small uh, uh, silicon chips is how much area are you using on the silicon? Because even though it seems like, oh well, they're so small, they must be cheap, they're not. When you make them in with one of these huge wafers that's like 12 inches in diameter, and there's thousands of parts on there, every square millimeter matters in the end. And I don't even know that that this. We, because of how hard you pushed us on making it smaller, we reduced the area between then and now by 87%.
Yeah.
So,
Well, that's even more than I thought. That's great. I think Jothy, it's all about economics in semiconductor. You look at a wafer and you can get thousands and thousands of these small little stamped out devices, but it still becomes, when you boil it all right down, one of economics and margin and raw materials providing that. So yeah, a square mil is, even though it may translate into a couple cents, when you multiply that out, it's real money. So but yeah, 87%, I have to admit that is more than I would have expected. And along with that, you also get the power reduction, which is
right.
another benefit.
Right.
So
I mean,
yeah.
you were pushing on both, but the motivation for us was first, we got to get the area smaller, because you had a budget for how much you were willing to give away to a third party like us, how much area we were allowed to take up on your silicon die, and we knew that making it a lot smaller would naturally make it use less power, and so we would get that win. And there's no free lunch in engineering, right? So you go, well, okay, it's smaller, it uses less power. What did that cost me, right? And
Yeah.
it turns out that what we were, we're trying to make the processor you're using really secure, and we were doing all the work in the silicon. And we figured out that, wait a minute, there's a whole bunch of work we can do up front once in the software. And then the hardware is even simpler, much, much simpler and faster, but also using less power. And the cost is that when you're trying to build the application, instead of it taking, let's say, 5 seconds to complete the build process, it might take 30 minutes, because it's
Yeah.
doing this detailed analysis, and you don't do that very often, and so it's a reasonable trade-off.
Absolutely. And I think, and I've always been an advocate of hardware software co-design and really and from the very beginning of the life cycle, because these benefits can get discussed and traded off, and it ends up usually with a better system. So I push that all the time. Is the software guys have to be working with the hardware guys from the very beginning of a product development life cycle, because these are the types of things that can happen. And you're absolutely right. The use cases that we were discussing at the time, a little extra build time up front, but better performance in the back end worked for those use cases. So yeah, it made sense to do that, but we wouldn't have known that unless we worked together, early on like that.
Yeah, and you had an architect whose first name was Joe, who was heavily involved with us, and what a prince of a guy to work with. I mean, just fantastic. And he was the one really that was on a daily basis saying, we got to figure out how to make this smaller. It was just,
Yeah.
But he said it nicely.
Yeah, he became a good advocate, and he obviously had the domain knowledge in both security and processor design, and you probably couldn't have gotten a more perfect person for this specific thing we were working on. So yeah, it was he had a lot of value.
I wanted to go over into the topic of business model, because I think, as you know, we kind of ran into a little bit of a buzzsaw. Dover did. And the timing was particularly problematic, because when things really got tough and we were starting to, run low on cash, trying to raise money was getting to be exceedingly difficult, because we were in the middle of the pandemic. And the specific issue, as I reflect back on it, is that I think that the business model that sort of is natural to anyone who's trying to sell to a big semiconductor company like where you were, is this idea of, or this model it's called hardware IP licensing. But and when most people hear the word IP, they think patent, but it's really is intellectual property in the truest sense. It's the design of the hardware, not hardware itself. So we would give you the design files, you would incorporate it on the chip, and you would pay us something for it. And the something was something a little bit up front, which was, we called it a design license. I think other people you buy IP from call it the same thing. And then there's a second component, which is the per chip piece. And this is where the law of big numbers is wonderful, because even if we were only going to get 5 cents a chip, but multiply 5 cents by 100 million, and it's significant, right? But the problem is, for a small company that is never going to get a huge amount of money from investors, because they want to see results for their money, like in 12 months or 18 months. And the time scales when you're dealing with semiconductors are pretty amazing. So from the moment that you might license it to where it's built into your chip, that's probably a year and a half. And then from that moment of, okay, you finish your design, now it has to go to manufacturing, and that takes, what would you say on average, 3 months or longer?
Yeah, 3 months probably, if you rush it through. Yeah.
Okay, and so now you've got packaged chips. These can be sold to your company's customers, and these are companies that make devices, things that like go in the electric grid or into a car, or these IoT devices we were talking about. But you guys covered 20, 30 different markets, I would think. But it still takes, now it's not until they say, I want to see a sample of this chip. They don't just immediately buy 1 million of them from you. And they got to they got some new things in it they got to figure out. So it's probably more time before they're going to they're going to buy any volume. Obviously, when you sell things to them, you then would pay royalties to people like us that
Yeah.
put this IP in. That's just an enormous amount of time, and I'm not sure that any startup should follow that business model. I mean, yes, it works for the huge companies like uh, like ARM, of course, the big one in the room here, and Qualcomm, of course, does this, and several other big companies, not that many, use this business model. What advice would you give for somebody that's got this cool idea? It's got to be implemented in hardware. What everybody else in this space does is license it using the same mechanism we just talked about. What should a startup do to try to succeed in such a difficult, long time scale market?
Yeah, and I think the time frame for those markets can vary quite considerably. Like automotive, getting into an automotive design in can take a lot longer than industrial, and that can take longer than consumer, right? So I think the first thing is, yeah, understanding, getting a clear sense of reality of how long it can take to get to volume, because that ramp time has different slopes for these different industries. And so, like you said, some can be quite long. So, yeah, reflecting on that, Jothy, yeah, probably more of this, whether it's more upfront or some other arrangement that does not rely totally on a fast ramp to get, to keep you sustainable in that area. I mean, I think the reason ARM can do something like that, or at least one reason, may be because they have a lot of different IPs and a lot of customers, and the phasing of all this is such that they can model a predictable revenue stream just because they've got a large number of customers and a large number of IP. But as a startup, like you said, where you've got a singular IP that's very innovative, how do you get to that revenue that you need to sustain? Yeah, I think one thing we learned is that we have to look at a slightly different business model where it's not so much back end loaded, right?
Yeah, it seems like it. And I tried to. So one thing we thought about a lot, but we couldn't afford, is this idea that you. So the one problem is that your company was trying to guess how much demand there would be for this level of security, because you're one step removed from where the attacks occur. No one attacks your chip directly; they attack a device, and then so and the devices in the medical world and the IoT world, the automotive, they're all very different, and so it's very hard. I fully understood that it's very hard for you guys to uh, truly characterize what you need to build in the way of security, and that you'll be able to get paid for. So what we thought we wished we could do was to create pull, to go out and for us to really explain this with the context of, here's the kind of attacks we think that are going to happen in the electric grid, and here's the evidence we have for that. And don't you electric grid providers want to see this, and therefore would they go and start to put demands on your company to to build that into the chip? And I got a tiny little taste of that because we had some real excitement from Bosch, and Bosch was ready to start putting some pressure on the chip providers, and it was just, that takes a lot of salespeople and a lot of going out and talking to their to those customers to create that pull.
Yeah, yeah. That's one. It's the pull from that side, and then it's from the others that are building the devices to look at a way of differentiating ahead of time that'll create pull in the market. You can attack it both ways. But yeah, that similar to what if you look at what's happening now in Europe with the Cyber Resiliency Act, there's kind of this mandate coming down about how products need to be secure in Europe. That's a top-down thing, right? It's kind of mandating a certain level of security. That didn't exist back when we were working together, but so there's a top-down aspects of it, and then the bottom-up where startups and like semis are just trying to innovate ahead of time and predict where that need is going to be. I think both are probably in some sorts necessary or can be valuable anyway. But we didn't have the top down as much back in those days.
No, we didn't. And the other, just because I think it's maybe interesting to examine different business models. And by the way, the book I have that's coming out has a big chunk of it is talking about different business models and how to think about them. But I'd always been enamored with Dolby's business model. Dolby's been around for a long time. I think they started in maybe 1965, somewhere in the 60s, and here's somebody that they really have. The company is dominated by a bunch of audio engineering PhDs, just developing amazing technology to reduce noise. And we all know them from back even with a cassette deck, it had the Dolby symbol on the front of it, right? You remember the cassettes. And so I did a lot of digging to see, well, would that model have made it easier for us? And I think it would have, because what they do is they have IP, so it's a design for a way to reduce noise in an audio processing chipset, and they would go to a chip supplier, and one of the main ones they started with initially was Texas Instruments, and they basically would give the IP to the semiconductor company and say, you have a license to it, you're not going to pay us anything for it, but we do contractually have to get one thing from you, and that's your customer list. Who's buying your chips? And the people that are buying those chips are, of course, the Harman Kardons, the JBL, the Pioneer, all of those people. There are a lot of newer ones too, but but Dolby knows to go to them and say, hey, you've got this amazing new noise reduction system inside there. Would you like to activate it? And then they have to pay a license for it. So you still have to wait until the time it takes to get it built into the chip and get out to the customers. But you just eliminated the high cost of the pull model.
Yeah. I think that you're right. I think that the other end of that perspective, though, is customer lists are sometimes like trade secrets. You just don't want to give them up. Companies don't want to give up their customer lists. Very, very valuable. So I think in some cases, Jothy, it's just very difficult to even get a customer list. I definitely get the point about then going to the customers and asking if they want this cool new feature enabled. But that first part, man, that can be really difficult to even get to that point.
Well, it certainly must have been in the very beginning, but at some point, it worked for Dolby because that's how it works, how their model works.
Yeah.
But all of these things are hard at the very beginning. I mean, even your story of ARM. I mean, I don't know the detailed history of the very early days of ARM, but how they actually got the flywheel to start spinning, because as you say, well, they got lots of different chips. I mean, they got lots of different IP that can become different chips, and so everything is all spread out, and what's coming in now is paying for the new stuff. It works great for them. Works great for the big ones.
And we kind of did that. One of the things ARM has been really good at is they get a lot of their quote unquote partners to help them, design their IP. They get input from a lot of these partners. So like, we'd be asked oftentimes to contribute ideas, and that they would take all the best ideas from all these partners as input, not direction, but as input to their new designs. And we kind of did that. You kind of got input from us. I think it could have been interesting if you had a chance to get input from, let's say, 20 or 30 or 40 potential customers, and kind of take the best practices or best inputs from all that. Would that have helped? I don't know. I'm just speculating.
I'm sure it would have. And we were talking to all the semiconductor guys, but I think timing is a big factor in the success of a startup, and
Yep.
And we were maybe just a little bit, not way early. I've been way early before. I've been a decade early with technology before, but we were maybe a few years on the early side. But I mean, now it's different. It's going after, Dover is going after government contracting work and doing okay. So I think RISC-V is an interesting enough topic to I wanted to pick your brain on it. You were heavily involved with it at the time. I don't know if you still are at your new company.
Yeah, a little bit, not as much as I was before, but of course we're looking at it because it's become pretty, very popular. Back when I first met you, people were still had a hard time even figuring out what it meant, but now a lot of people know what it is, and but we're involved.
So I think a lot of people thought it would take off faster than it did, but what I've seen over and over again with new technologies is that while you're in it, it seems like it's taking longer than you thought. And then you look back on it after 5 or 10 years and you think, wow, that happened fast. So where do you see it going, and how quickly? It's complicated because China seems to be making a big bet on it, but sort of separating that out, just the natural flow. What do you think is
Yeah, when I was on the board of RISC-V, I was pushing really hard on the software support for that ISA, because I truly believe that an instruction set architecture is only as good as the software ecosystem around it. I still believe that, and most that's how companies like Linaro got started, was to provide software, open source software support for ARM. And so I thought RISC-V would not be successful unless they really started focusing on software. So that's what I did when I was back there. I think they have come a long way on the software side, at least for microcontroller. I think there's some other big lifts they have to make on the server side, if you will, or enterprise side. But I think they're making really good progress there as well. That they formed RISE and these other consortiums very similar to Linaro that are driving RISC-V software support. So Jothy, I think it's going to continue to be successful. I think it's become part of the natural discussion now around ISA selections for different types of markets. So I think it's here to stay. I think the investment in software is finally happening. So I think it's got a good future ahead of it. I do like the fact that it has been designed from the bottoms up to do instruction extensions fairly easily. I think the challenge is still that how many people are actually using instruction extensions instead of just the core architecture. And then when you start using those instruction extensions, preventing fragmentation in the market, whether it's a compiler version or what have you, to support the instruction extension. So the fragmentation still exists. That challenge still exists. If people really do start extending the instructions for areas like security or ML, or things like that, it'll be interesting to see how how that evolves.
I think that a lot of people underestimate how critical that huge body of software and all the libraries and the compilers all being fully up to full functionality on the particular instruction set is you look at processors of the past and how much software exists, whether it's for various Intel parts or all the various ARM parts, and ARM invested themselves a huge amount in all that software. Some of it that they even open sourced, I believe.
Yeah.
It's
That's that company Linero that I was mentioning. That was formed from industry collaboration to provide open source software for ARM because they really wanted to try to catch up to, at the time it was x86. So that's how seriously they took it that they formed this company to go drive that. So it still exists today.
Yeah. So I wanted to get your perspective on. So you've worked quite a number of years at the previous semiconductor company. You're relatively new at this your current semiconductor company. Are you allowed to name where you are now or not?
Probably not right now.
Okay, good. I'm glad I haven't slipped and said it. So, but you've been in and around startups while you've been in this role. So, have you ever been enticed or interested or to start one yourself or to join one, a startup?
Yeah, I haven't really been motivated to do a startup myself. I just haven't. I'm a little bit more risk averse in that area. Uh, I just enjoyed my time at larger companies. I always felt that eventually, before I kind of rode out into the sunset, it would be cool to join one or try one after I quote unquote retired. But I've never started one, never been involved with one. It's just an area I just haven't had a chance to get involved in.
Well, I'm sure you're well aware that people in startups, are, it's very different. You can make decisions really quickly. There's like relatively no approvals needed for things, and so a lot of people think that innovation is going to always come from small companies, but I know there's quite a few people that work inside of large companies and think that they are certainly not dead to innovating. And what do you think it takes, or maybe you want to take it from the standpoint of why things that are going on in big companies maybe slow some innovation, and how you can snap them out of it and make them back be innovative, even though people are working in a big company.
Yeah, no, I think first of all, I think some of it comes down to culture. So certainly to your point, large companies can innovate at a tremendous scale. Where I am now, the culture is one of innovation. It's been that way for many, many years, and it still continues to this day. And I think a lot of that is part of the culture, and that starts top down. Because a lot of, especially big companies, talk about it, but very few of them do it really well. For example, in my team, I've got a very large software team, but I still follow the kind of 60-30-10 model where uh, we carve out, time for innovation, and knowing that some of these will not pan out. But that model has worked for me for many years. We still do it. I do it with my team now. And if you've got the right support at all the levels in the organization, it makes a big impact on people's ability to innovate. Having said that, we also have a central, we have an innovation center that we use exclusively for, I'll say moonshots for really crazy stuff. And we know that some will fail and some will succeed. So the culture, the infrastructure, and the support are three key things. But with that, even large companies can innovate at scale, actually. So it's possible, but you have to have the right things in place.
So is that what attracted you to this new company, this culture?
Yeah, definitely. The culture is one that encourages innovation, and a lot of the products we build, we do differentiate based on our innovative culture, and so it was one of the reasons I wanted to come here.
And luckily you were able to stay in the same city you lived in before.
Yeah, yeah, I do a lot of shuttling around, but
I think we could
as we
safely
keep
say it wouldn't give away anything to say what city you live in.
Yeah, no, I'm in Austin, Texas. Yeah, I'm still here.
Yeah, and thank goodness you weren't wearing your cowboy hat today. I mean, usually you wear
Yeah,
it.
yeah, yeah. Well, I grew up in New England, so I never got too used to being a cowboy. So you won't see me wearing one.
Right. You went to Worcester Polytechnic.
Yeah, I did. Yeah, yeah.
So
Down here, a lot of people don't remember, don't have never heard of that.
so I'm talking to you right now from Wayland, Massachusetts. Did you live in a suburb of Boston at some point?
No, just Worcester. I had some. I actually had lived for a period of time, just for 6 months in the Back Bay, for a while. That was really fun. But grew up in Connecticut.
Oh, Connecticut. Yeah. Well, we up here in Massachusetts, we forget that that's still part of New England.
Yeah, sure. Yeah,
I,
yeah,
I, we shouldn't. We shouldn't. They still root for the Patriots and the Red Sox.
that's right. Yeah.
So, I've asked a bunch of questions, and is there something you sort of wish I'd asked, and something you want to talk about before we wrap up?
Well, first of all, looking forward to your book. Definitely want to read through that. No, I think you look at there's this ecosystem of technology, including kind of larger companies, startups, and I think there's uh, how that ecosystem collaborates to innovate and get real products out the door. It takes a skill, and it takes experience. You've had multiple startups, so you kind of get it. And I think for me, it's always a joy to collaborate with that ecosystem, whether it's software, hardware, systems, on new ideas, and it's something that I continue to learn from each time I go through one of them. So it was learned a lot from the one with you as well. So thanks for all that.
Well, you're welcome, and it was a pleasure on both sides. One more thing about the innovation stuff and big companies, because I do a little sideline occasionally where I consult, especially for defense contractors. So they're huge companies, and they're way more constrained than even a big company that's commercial, because they've got so many rules from placed on them, A, by just being a government contractor, and B, by the fact that some of their work is classified, and so they've got those constraints. I'm talking to one right now where um, it, more than 90% of their software development is done in what's called a SCIF, which is a secure facility where, and most of them, like almost all of them, are windowless.
Oh yeah.
And but it turns out that there's some studies that have been done about productivity of not just engineering but of anyone who's in a windowless office, and the productivity drops by between 5 and 40%, depending on
Wow.
some other factors.
Interesting.
Like, for example, if people are encouraged to get up once an hour and go out and try to go outside, that helps break that down. But one of the things that I always like to explore, because everybody who's building software talks about quality, but some are really struggling to actually have good quality software. And do you keep track, for example, of like what ratio of developers to real, QA, hands-on QA testers is?
We do in some areas, yeah. Like in automotive, we're at about 1.8 developers per tester. In other areas like consumer, it's not as good as a ratio. There's more developers per tester, but we do track some of that where we need to. And
So you
I think,
do you realize that 1.8 to 1 is phenomenal? So, based on the work I've done, standard in sort of the best software developing companies is typically 4 to 1, and shockingly, at some of these companies I've been talking to, you're not going to believe it, it's 40 to 1.
yeah, yeah, yeah. No, I do believe it, Jothy, because I've been in places like that as well. I'm pretty proud of that. Our battery management team, software team, is the one that it was 1.8 to 1, and yeah, they get it, and obviously it's got to be really high quality. Functional safety comes into play, so it almost demands that level or that ratio, and if it does fall off, it does fall off in some of these other areas like consumer. Not that it's not an excuse. We have to do better there too, but it's just, it's been like this forever, right? People, they value development, and they just don't value the testing discipline as much. I think it's really important. I think you can actually learn a lot more to test something rather than developing it. So
Yeah, and I always tried in all of my companies to make sure that QA was considered a first class discipline, not one where, so I couldn't get it into this company as a developer, so I went in as a QA engineer. Well, that person, bless their heart, but that person is going to keep advocating till they get moved into a developer role, and so what you really want is you want to find people that they like the discipline, just as you said, but they like the discipline of, essentially, it's not that they want to break things, it's that they want to make sure that somebody else doesn't break the thing.
yeah,
Right?
yeah, yeah. No, exactly. I read a great article from about the shuttle software. Back when I was still flying, it was called "They Write the Right Stuff," and it was all about how the development team and the testing team had this healthy tension. The development team wanted to write software that the testing team, could not find any bugs in it, and vice versa. They got along fine, but the nice healthy tension, and they had some of the highest quality, obviously, of any software you can think of, but having that kind of nice healthy competition, I'd like to emulate that or try that in one of my teams one of these days.
One of the things that we did, just as a quick, maybe last point about this, is that, and this was when I was working at Borland, and at the time, Borland was, and most people listening to this will never have heard of Borland, unfortunately. But at the time, it was the third largest software company in the world, behind Microsoft and Lotus, and then Borland. And it was widely known, especially around in Silicon Valley, as the one company that was building the highest quality software. And they had 2 million developers that were buying, their products, and they were the most demanding customers. And so they wanted to ship a product every year. And so they divided that up into, okay, we're going to develop new features for 6 months. And then they would do a beta 1, a beta 2, a beta 3, and a gamma. And during each of those, there would be an all-team bug hunt. And I was responsible, since I was running the division, I would pay out the awards. And by the time we got to beta 3, somebody finding a crash bug would get a $1,500 payout. And in gamma, if you found a crash bug, we were feeling really scared because we were supposed to be about to ship, right? Yeah. So, but we made those so much fun. The QA team ran the whole thing, and they were the ones that were, kind of walking around and making sure that developers who were, stovepiped and they worked on this thing but they were supposed to test something that was different than their area. So they were getting a new perspective on the product in another area. And they might not know how it worked because not all the documentation was fully up to speed yet, right? So it was fun. It was like this, party atmosphere, but it was serious too. Everybody was working hard, and you kind of a little competition. Hey, I found a crash bug, and how many bugs did everybody else find? And but it worked. It really got everybody working. It made the QA team feel, valued, which was my main goal. And it was, and we found some bugs that really glad we didn't ship with.
Yeah, I think having these types of competitions, both on like the development side, like an innovative new algorithm, or on the testing side, does drive a certain level of camaraderie, and I think they are interesting programs. I think that sounds like a great idea. What you did, what I'm doing now, kind of on the total opposite end of the spectrum, is looking at how I can be more efficient generating test cases using generative AI. We've come a long way, right? That's
awesome.
But there's actually some really cool stuff going on with that too. So I'll take anything. If I can get the human out of the loop in some areas, I don't mind doing that. But so I'm looking at that right now. See whether that can help.
I can imagine how it would. I mean, coming up with it's very hard to figure out how to test something and kind of cover every possible thing that could happen to that system, and potentially make it go awry. And boy, the more that we're having our devices controlled by AI, the more important that is, because if that goes haywire, and it's controlling a system that could hurt somebody, that's a really big deal.
Yeah, exactly. Yeah. I agree. So some of these industries, like industrial, where you're controlling very, very sophisticated robots, same thing, right? It can be, that's why functional safety is now pretty much all over the place in industrial as well.
Yep. Well, listen, it has been such a pleasure to talk to you. I don't think we've ever sat and just riffed for an hour. What a great thing. Yeah. So happy for you and your new role. And I hope to hear more about it. But I think all the listeners would agree with me that it was really great to get your perspectives.
Oh, yeah. Same here, Jothy. It was great talking to you as well. And definitely good luck with the book. Like I said, look forward to reading that too. And let's stay in touch.
Okay, we will. Thanks very much. It's going to be a wrap for today. Thanks for tuning in to this week's episode of Adventures on the Can Do. Please share and like us on your social media channels. This is Jothy Rosenberg, and I'll be back with a new episode every Wednesday morning at 9 a.m. Eastern Time. Don't forget to check out the show notes for additional resources and links. Hasta la vista.